Okay, so we are back. And next up, we are going to discuss using APL in academia. And we have a panel. Some have been introduced before, but new people here are Jesús and Stephen. So, Jesús, do you want to briefly introduce yourself?
Yeah, sure. So I'm working, I'm a metallurgical engineer. I work in mechanical engineering, material science, mostly in the field of computational material science. So everything related with programming computers for everything related with metallurgy. And I'm working together with Ghent University in Belgium and with Dyalog, trying to apply APL to my work in metallurgical research, and also more generally trying to bring back APL into academy and try to show people at the university what APL can do for them.
Right. And Stephen, do you want to introduce yourself a little bit? What do you do?
All right. Yeah, my name is Steve Mansour. I've been using APL for about 30 years now. My background is I worked at, I first encountered APL at IBM. I worked there for 12 years at IBM, and 9 of those years I was an APL programmer, developed software for reliability analysis. After that, I worked for a company called Security APL, which was located in Jersey City, and I developed software, portfolio management software, billing systems, and things like that. And then after that, I worked for the Carlyle Group, developed mortgage software, and this was again in APL. We had cash flow optimization models and things like that. And then I got into teaching. I started teaching statistics and mathematics at several colleges as an adjunct professor. And while I was teaching statistics, we were using statistical software such as Minitab and SPSS. And I found that the software was kind of lacking. It didn't really quite fit with my philosophy of teaching. So I wrote my own, and I developed a system called TAMSTAT. And so I'm pretty much a freelance software developer right now, in addition to continue to teach. So that's my background.
Okay, cool. And Santiago, we already heard from and some of what you do. But let's also hear a bit about what you actually, how you use. Obviously, Santiago just told us more about what he uses for, but Santiago, you spoke about how you've been modeling these kind of things, but you also use it to teach people these subjects as well.
That is correct. Something we've been trying to do is provide a series of workshops internally to NCSA personnel. So basically, we are a collection of varied individuals across multiple science fields. Some of us are computer scientists, some of us are physicists, some of us are things we could usually not find in a regular crew of programming people. And for the first experience I had teaching directly APL was with Marcus Frankel, the developer of QAPL that we have now. And he ramped up in 2 months, and he was producing working code very directly. It was very eye-opening to see someone started from zero to full production in a short amount of time. And Stefan's book actually was strongly responsible for that, I have to say.
That's good. And here's just you're teaching relatively advanced subjects. Do your students learn APL as part of this and then use that to understand what's going on, or?
Well, they don't formally. I see with the students we have with the students in general, but with these ones in particular, they don't want to know that they are learning APL. They don't want to learn a programming language because they are in a course, I don't know, about crystallography, for example. So for them, having to learn a programming language is an extra task they have not thought about, and it's not something they want to do. And then you have to be very careful to make it look like you are not teaching them APL, but you do. And for example, I find it really useful in the Blackboard when you have to discuss some complex topic and you have a Python program and you are discussing in a Blackboard. After a while, you start doing diagrams and boxes because writing Python code is not useful. And then you can tell them, okay, instead of a box, let's use this little symbol when we want to rotate something. And let's use this little symbol for summation instead of that one because, and slowly they are learning APL even if they don't know. And I think that this is a good way for them to get into APL because they see the advantage before having to see the bump, the learning bump you have. So yeah, I'm trying to use it, but in a bit indirect way.
That's very interesting. It kind of brings APL full circle to its origins on a blackboard. Trying to describe algorithms and traditional mathematics, just failing at that. It always states kind of what is or what's the relationship between things, but not how you go from something to something else, some process like that. So that's very interesting. And what about you, Steve? You teach statistics, right? But you have this application you've written over the years.
Yeah.
Timestat, it kind of packages up the APL and people don't really see the APL. Do you expose your students to actual APL code as well?
Actually, I do. My program does handle a lot of the details that they don't have to deal with. But I still, it doesn't do everything. And so I still have to rely on teaching APL. So I was trying to do kind of what Jesús was doing also was just introducing some concepts on an as needed basis. So once in a while I can tell them how to do a summation or something like that as necessary. But a lot of my functions were designed so that the user can really type in an expression that's somewhat English-like. So for example, in the case of, like, say, the normal distribution, you can say normal probability greater than 1.2, and it will give you the answer. And I'm using an operator called probability, and it takes normal as the normal distribution is a function in Timestat, and greater than is also a function, and it's a dyadic operator, and the number 1.5 or whatever it is on the right is just the right argument. And it reads very English-like, and so a user can just type that in and get a result. And that's kind of the way I designed it to work. I've also written a user interface and a wizard that will build an expression. So some of the more complicated statistical distributions and things like that can be built using a wizard, which it's just basically a screen that has inputs and drop-down menus and things like that. And I worked with Michael Bass on that to develop that. And we have, and so there are several ways to do that.
Okay. Well, yeah, that's interesting. And you just answered one of the questions that been asked in the Q&A and interface, namely, if it's fruitful to introduce APL in the context as needed, and just like mathematics is always introduced. Nobody it goes ahead and learns everything in mathematics and then they go and attack problems, right? They're always piecemeal. I don't even know if anybody knows all of mathematics anymore because it's large. And so I think we can distinguish them between two different ways of learning, or two different things going on with learning APL. I've gone out to schools with one of my colleagues and spoken to classes of students and teenagers. There, the goal was very much to show them APL. Whereas what you're all describing, I think, Santiago, did you? I don't think you mentioned how exactly you do it. You don't teach them APL either, right? You also just add it piecemeal as they need it for the things that you're modeling, right?
For the case of quantum, we started from Thomas Wong's book, and with Marcos, we started building up. Since most of quantum mechanics is matrices at the level that we need to,
Right.
then matrices in Hilbert spaces, that means we have complex numbers, and the matrices all have size 1, the vectors are all norm 1. Then we could reproduce exactly bit by bit what the book was saying. It was incredibly useful, and then you could play with the notation directly.
Without even needing any libraries. It's just
Exactly.
It's also often the case. I don't know. I guess it happens in the field of Santiago too, that you need a custom notation anyway. If you read 4 different papers, you will have 4 different notations that you need to learn. So learning the few APL symbols that you need to understand what you are doing in that moment is something that you have for granted, that you can assume that everyone in the field will be able to pick up a few symbols and work with that. And maybe that's not usually the case when you're trying to teach programming language.
right. It's very different when you're trying to teach a programming language, and then you go like more systematically. These are the features within this area. So I guess it's for everybody to adapt as they see fit. And it's very interesting. And this using it just as a notation. So they might not even know that it's APL because it's just being introduced as a way to write these things out. But Stephen, you mentioned being English-like, and if I remember right, some of what you have allows writing out words or using the corresponding APL symbols where those symbols exist. What's your experience been like there with do the students prefer one or the other?
Well, I use I've written several cover functions for some of the APL primitives, like you can use LE for less than or equal to, things like that. But for the most part, I give them examples. I create slides with examples of expressions on them and show and so they can kind of reproduce that and then just modify it as necessary. And so I've found that those I create slides and I present them in the class, and then I kind of I post the slides to and so the students can access them and review them later. So they do have examples of how to use APL and everything. I get kind of mixed results. Some students adapt to it fairly easily. Others, they will just copy the lines and they don't really know how to modify stuff. And so I have a little difficulty with that. So as I've been developing Tamstat, so it's, a lot of times I create more functions or create more functionality to handle some of these weird cases that come up. And so as I look at some of my old slides and I say, oh, you don't need to do all those lines and expressions. I can just build a cover function to handle that case. And so I've been doing a lot of that.
You add layers of abstraction as you need them.
Actually, yes, that's the case. But I found that I've been teaching some more advanced. Recently, I've been teaching more advanced statistics courses, and so the basic functionality that I had written into the original program would serve a beginning stat class, but it didn't handle some of the nuances of the more sophisticated things like ANOVA and regression and things like that. So I sort of adapted and added more functionality to the system to handle these cases. And so the students now But before I could always use APL to generate, to do anything that I needed to do, and I would have them do it, and I just give them lines of code to do it. But now I can just tell them use this function, and so that kind of helps. So a dialogue will kind of do. I mean, Camstat will do 90% of what they want, and then the extra 10%, I just use plain APL or APL mixed with some of my functions to do things. I have found that sometimes I want to explain a concept, and so Camstat does too much, and so I just take them through and show them basically line by line code to generate the result that I want to get. And then I say, oh, by the way, if you in Camstat, we have a built-in function that does that. But I do show them because I want to explain how I want them to understand the mathematical underpinnings of various types of tests, statistical tests, and things like that. So I do that.
And what about you, Jesus and Santiago? You also build abstraction layers on top of things as you go along? Then, and if so, then do you find it useful that people can drill into those to get a better understanding what's actually happening underneath the surface?
Absolutely. I think that especially in a field that is emerging, again, going back to the case that has been more studied in our center, you need people to look at all the details. That is the subordination of detail that Iverson talked about. You want them to know that they can use the function, but they also need to learn how the function works. But they need to concentrate not on how you tell the computer how to do it like imperative languages, but you want them to understand what the computer is solving. That is a very different kind of understanding.
For me, what I see as a very good advantage is how interactive APL is. For example, some of the work I do are models which are cellular automata, so you have one cell and you have to worry only about its neighbors. With APL, I can have my whole problem and have my function which says solve problem, but it's very easy to define a very small problem with 9 cells and take one line from that function and see what it's doing and how it's moving everything and so on. So, yeah, I can show them these boxes, but it's very easy to go into the box and see what is inside the box and see how it works with real data. So, yeah, there's something I try to do that they not only have the initial and the final result, but with APL it's very easy to change in and see what's actually happening in the middle. That's something I try to take advantage of.
Cool. And what about your colleagues then? And you're all in institutions that have plenty of people around you, and are you the only ones using APL? Well, Santiago mentioned some other people you're working with, but on the same level as yourself, there must be others. Does anybody else like yourself use APL, or you're the lone promoter there?
No, not really. In my department, not really. I'm trying, and I hope at least a couple of people will start using APL, at least for some things. So at this point, only I'm using it, but well, maybe some students are starting to do some things, but yeah, the conversation I have with my colleagues are not in APL, let's say, unfortunately.
Have you tried showing them some of your things?
Yes, I try, and I think they can at least see why it's interesting.
Okay.
Because, yeah, only because of that, because you are talking about something and you can say, yeah, but I will show you, and you fire up the interpreter and you define a small matrix and you can show them what you actually mean instead of having to draw it in a paper or wait for 2 weeks to write a program. You can go there and show them. And there's something that they appreciate it, and think they have in their back of their minds, I want to do this too.
I hear. What about you, Stephen? Did you have you had colleagues react to this, or you tried showing them some of the things you've been doing?
I'm pretty much a lone wolf right now. I mean, when I worked at IBM, I worked around other APLers, and when I worked for Security APL and the Carlyle Group, I worked with other APLers. But since I've been mostly teaching, I'm pretty much a lone wolf when it comes to APL. But one of the things I wanted to mention was when I introduced APL to students and everything, I found that when I write coding, when I write Tamstat, when I developed Tamstat, I found that I wanted to keep the philosophy that APL is a tool of thought, and I'm trying to express an idea. So I'm teaching concepts of statistics, and I'm trying to teach them just an APL concept. So in statistics, we have different types, families of functions. Like we have statistical distributions. They all possess certain characteristics that make them related to each other. And then we have what we call summary functions like mean, standard deviation. And basically, the concept is you basically take a vector and you convert it, and you input a vector and you get out a scalar. And so I kind of asked them in the beginning of the semester, can you describe your summer vacation in a single word? And that's kind of what a summary function does. Like the mean is just a single value that expresses all the items in a vector. It kind of summarizes them. And so I spend a lot of time. I spend a lot of time talking about functions, arrays, and operators and namespaces are designed are not only for programmers but also for users. And functions, arrays, and operators I think are as my colleagues here expressed are an integral part of scientific inquiry, because I think of that. And so I find that designing functions for user functions, is more important than the actual coding. The coding inside can be as illegible and unreadable as possible, just as long as what the user sees is simple to use and it's flexible. I like to make my functions flexible, sort of forgiving, so that users can take different types of inputs. So one example of that is a vector is a good idea of a data set. You know, when you have a list of all student heights, for example, and I can represent that in 3 different ways. I can represent it by just the raw data, which is just a vector, or I can represent it by, let's say, a frequency distribution, which lists, let's say the heights and then the number of people that are at that height. Or I can represent it by simply the mean, like the count, the number of the sample size, basically, the mean and the standard deviation. And I can take any of those 3 inputs and do some calculations on it. And so the users can input data in many different ways and still get out the results. So data representation is an important part of Tamstat. And so that's kind of where I'm coming from with this.
And Santiago, what's your experience, colleagues, reactions?
So it seems to be in a gradient of this is quirky, interesting character set for the programming, down to intriguing, to oh wow. So we've had all the range of reactions. But to what Stephen just said, there's something very important that at least I found useful APL for, is generating test data sets, synthetic data. We face many times the challenge of not knowing what our experiment will look like, but we know the theory. And by having the synthetic data set, at least we know the code works, which is really important, and also we know what to expect. And if we don't get what we expect, then the theory is wrong. And that's very interesting. That's the point where you make science. So it's, as you can tell, I am really happy in APL land at this point.
Well, yes, you said you write most of your code today is APL. What about then? So being that you're all basically lone wolves with interesting reactions around you, have you had issues with what you have created and communicating with other types of systems, and where you're trying to hook things together?
Well, there can be some resistance at first. That's a given. I mean, if they expect to see a presentation about metallurgy and suddenly you put there a bunch of APL symbols, yeah, the first reaction is a bit, why do I need to learn this new thing? But I think that the ones you explain it like, yeah, this is just another tool and it actually helps us to get our work done. Once they realize that, I think it's fine. But yeah, at first there can be some resistance.
And have you had to have your APL code interact with programs in other programming languages somehow, sharing data or direct interactions?
Yeah, I'm only saving data because normally the data we have, it comes from some device, from some machine, maybe from some simulation, from some other software. And yeah, you need to interact with that in some way.
Ah, so that's just data sharing. Santiago, you were nodding. You've had your systems interact directly with other systems?
Yes, we are starting to work heavily on having our code in APL interact with real quantum systems. This is something that takes about a year. And there's something called quantum assembly language. I put the link in the webinar chat. And basically it is, again, something like Verilog, but what we are trying to do is to write the code generator for OpenChasm from QAPL. And that way it's going to be less of a transition for users once they're familiar. And also it will allow us to run actual code on systems. But yes, it's I think that the burden of the proof is in those that propose the solution. And this is very true.
Very nice. Okay. And for the attendees here, this is your chance to ask any questions from this panel about teaching. So you still have a minute or so. Otherwise, we can always answer questions in chat and QAs later. Many of the panelists will be available throughout this whole thing. And I've been out there teaching, and as I mentioned, school kids, and I had some interesting reactions. I mean, obviously, some students just don't want to learn anything, others are more mathematically inclined than their classmates. But I've found that children are generally much more open to things, and they don't come with a reaction like, "Oh, this looks weird," because they're not used to anything else in particular. Though the ones that have been out and teaching, some of them have had exposure to other programming languages. And I remember in particular one day when we were out in such a school, and we were going through some things on the whiteboard, and each student is by a computer trying out some things. And a girl exclaims, "I'm not going back to Python after this." And because some things are simply easier done in APL, and for those kids there that they're teenagers, they might be a little bit lazy. I think they appreciate just being able to express things concisely, as little effort as possible. So
well, it's true that when you start using APL, people ask you why you like it and what's so great about it. Sometimes you have a hard time explaining it. But if they ask you if you would go back to some other programming language, then you automatically say, no, I will do this in APL. I'm totally sure.
Okay, cool. That's our half an hour, and we'll be back after a break.